3-1 Form G, solving systems of linear equations using tables and graphs. This is it using graphs. I'm going to give you examples, odd examples 1, 3, 5, 7, 9, and 11. So right here, we have number 1. I wrote step 1, rewrite in slope-intercept form. Step 2, graph using slope-intercept form. And step 3, substitution. I spelled that wrong. Let me go back and change that. Substitution. Alright, so you have your system equations. Y equals x minus 2, x plus y equals 10. Step 1, you're going to go ahead and put in slope-intercept form. So only one of them needed to be changed. Then in step 2, you're going to go ahead and plot your point or find your point using slope-intercept form. You know where it crosses at the y-axis of positive 10 and negative 2, and then you know what the slope is. After you do that, you're going to find that this is 0.64 right here. Then once you have 0.64, you're going to plug in. In step 3, you're going to plug in and you're going to do your substitution and find out that 64 is correct because both of your substitutions are equal to 4. Number 3. I'm going to back this up for just a second. Hold on just a second. Wider view. Alright, so in this one we have the system equations of x minus 2y equals 10 and y equals x minus 11. Y equals x minus 11 doesn't need to be changed. It's already in slope-intercept form. The other one, though, needs to be changed, and it will come out to be y equals 1/2 x minus 5. You'll go ahead and plot your points. You'll end up with 12 and 1 as your point intersections. Then you'll go ahead and plug those in, and checking your answer using a substitution, and they both come out to 1. Next one, number 5. Number 5, your system equations are x plus y equals -1, x minus y equals 3. These two, you have to do both of them. They're both written originally in standard form. Then you have to change it to slope-intercept form. Once you change into slope-intercept form, you'll find out that, and graph it, you'll find out that it's 1 and -2. You'll plug in your stuff, and you will check your answer. Number 7. In number 7 and all of them, make sure that you're watching your negative signs. They can get lost real fast, and so make sure that you're paying attention to that. So, in number 7, the system equations are 4x plus 3y equals -16, and -x plus y equals 4. Both of these need to be changed. They will be changed to y equals x plus 4 and y equals -4 over 3x minus 11 over 3. Once you graph those, you'll graph them, you'll end up with -4 and 0. Plugging that in, you'll do your substitution, and you'll find out that is correct. That was number 7. Number 9. When you do number 9, your system equations will be y equals 2/3 x minus 5 and y equals -2/3 x minus 3. You'll find out that if you keep it in fractional form, you'll find out that it's 3 over 2 Your point is 3 over 2 and and negative 4. Once you plug in, you'll realize that they cross out, and this is where you really need to pay attention to your negative signs. And if you want to change it to a decimal, that's fine, but just make sure that you're doing your math correctly. The last one, number 11 in this set, you're going to do the system equations of 2x minus 4y equals negative 4 and 3x minus y equals 4. Both of these are written in standard form, so they must be changed to slope-intercept form. You'll do the work. Don't forget that when you get to y and y is negative, you still have to divide by negative 1 across to get rid of that. Then whenever you come over here and you're working on your plot points, just pay attention to your points and make sure that you're looking at the point in which they're crossing. Then at the very end here, you're going to make sure that when you're substituting, if you can substitute or cross multiply them both out, don't lose that that's actually equal to 1. So, and then that makes it 2 and 2 and 2 and 2.